So the question is how to use Tomcat with integrated Eclipse or standalone. We're going to use it standalone because of the fact that I find that when running an Eclipse, well, the Eclipse is notoriously memory hungry and it's not very stable sometimes. And so running Tomcat within Eclipse, while it has its advantages, like for debugging, oftentimes it's not you're not as productive as running it within Eclipse. And I'll show you. Sorry, you're running it independently, and I'll show you, how you can do both. Although I generally never run it within Eclipse. Okay, so we're all back. Let's go and discuss. Let's go and set up Tomcat. So I happen to actually have my Tomcat already running. So let me show you what I did with mine. So. Okay, so all I did is in fact, let me do this again. rm-fr apache tomcat bye-bye. Remove tomcat bye-bye. And now I'm going to do is unzip, or in my case, I'm going to do the tar zxvf of the software apache tomcat 30.tar.gz. So in your case, you hopefully downloaded the .zip file. All you need to do is unzip it somewhere, okay? Hopefully you don't have to unzip a file. Where you unzip, it's not important, but I do recommend putting it somewhere where it's close to the root of your drive and not in a directory that contains spaces, okay? So like create a directory, on the C drive called, I don't know, Java training or something like that, and, just put it right there. So I'm just gonna unzip mine here. And I'm just going to, in my case, it's simpler if I also set up a symbolic link so that I don't have to remember the long version name like that. But my Tomcat is in, /training/Java Web Dev /Apache Tomcat 6030. Okay? Now, how do I get Tomcat started? Actually, just before I get there, how many of you have used Tomcat before? Okay, cool. So that's perfect. So we can actually go should be able to go through this quite quickly. So you cd into Tomcat, and I highly recommend we do this from the command line. I know at Tomcat, especially if you install it as Windows service, Windows installer, you actually get a little thing in the bottom right where you can start and stop it. The reason why I don't like you to be doing it like that is because I want you to have a Tomcat console available in front of you at all time, which is basically I want you to run Tomcat in the foreground, so when things happen, you can see them in real time, as opposed to have to wait and open up log files and close log files. It's just too painful. Okay, so go open up your command prompt, which you all hopefully are comfortable with. Go into the Tomcat bin directory, and you'll notice that there's on Windows, you'll notice there's a bunch of files in this bin directory, some of which are .batch, some of which are .sh. Obviously, you guys don't care about the sh files. I don't care about the batch files because we're in different systems. But for all of these files, or pretty much all the files, they're equivalents. So basically, for example, for Catalina.batch, there's a Catalina.sh, and so on and so on. So whenever you see me, for example, doing something like Catalina.run, you can type, as opposed to this, you can type, Catalina run. You can omit the .bat extension because Windows will take care of that for you. Okay? So don't get confused about, me being on a different operating system. Ultimately, it's all the same. Okay? Now, Tomcat, for those of you that don't know, is a Java EE, partial Java EE implementation. It implements servlets and JSPs, or provides support for servlets and JSPs, clustering, basic management, and monitoring. Okay? It's actually one of the most popular servlet-only application servers out there, and it's actually by far the most popular application server out there in the Java EE land, even though it's not really a full-blown implementation of Java EE. So there's quite a few companies out there that use nothing more than just Tomcat. They may have Apache in front of Tomcat as a web server, which is not required, but sometimes people think that this is a requirement. But that's basically one of the reasons why, one of the ways they run it. But Tomcat is a full-fledged web server, in addition to being an application server by supporting Java web applications that do servlets and JSPs. Now, where I got Tomcat from, just to remind you, is I went to tomcat.apache.org. The version 7 came out very recently. Like I said, I don't want to risk it for this class. We're using the latest version 6, which we downloaded from here. The reason why I wanted you to do the zip version is because the zip version is basically it doesn't force you, but it encourages you to run things in the foreground so you can kind of see what's going on, and it's better for development than running in the background as a system service. So that's really the reason. And also the Windows version also ships with some Windows-specific binaries that change how we use SSL. And later on, I'd like us to have a simpler way of using SSL. So just makes things a little simpler for us. Okay. Now, I made just one correction I wanted to state. Unfortunately, obviously lost track of my calendar here. The San Francisco Java user group event that I said it was happening tomorrow. It's not tomorrow. It's the next Tuesday. And if any of you want to learn more about Tomcat, we just so coincidentally enough have an event coming up in March, second Tuesday of March, on Tomcat 7 by a person called Jason Britton, who happens to be the author of the definitive Tomcat for Riley. And works on Tomcat at a company called MuleSoft that actually provides a commercial implementation of Tomcat. So he's going to be doing a talk on Tomcat 7 and what's new and why is it so cool and so on and so on. So if any of you are, again, in San Francisco and can afford to come to this event, I highly recommend you do. You can sign up for it at sfjava.org. Okay? So that said, Tomcat used to be a reference implementation of servlets and JSPs. It's not anymore. It's now a full-blown. It's just a separate implementation. The full-blown Glassfish is the reference implementation of the entire Java EE spec. But Tomcat is a very clean implementation, very light, very lean, very performant. It comes with just the right set of features. It's very mature, tends to work really well in production. People use it, enterprises use it all the time. Our business has been running on it for, 5 years, and so have others, before then, and so on and so on. So it's a very, very solid, technology to be basing your, even supercritical, business operations on. Especially because you can very easily cluster it, so you can very easily scale it and provide high availability through it. So that's what we're going to use. We could be using, in this class, the Spring and Hibernate stuff is not in any way going to be dependent on Tomcat. Servlets and JSPs are not dependent on Tomcat. Anything we discuss can very easily be ported to WebSphere, WebLogic, Oracle's stuff, whatever, Glassfish, anything else that you can think of, as long as it's Java EE compliant. Okay, so no way should you think this is somehow specific to Tomcat. Just like later on when we use MySQL as our database backend, it's not going to be, none of our stuff is going to be dependent on MySQL. We might as well be using Oracle or something else, DB2, if we didn't, if you wanted to bother installing, bigger piece of software and dealing with licensing issues and so on and so on. Okay, so it's all very, very transparent as far as the actual whatever the engine is behind the scenes. So coming back here, so to start Tomcat, all you need to do is first make sure that you don't have anything running on port 8080. Okay, now I don't know if you have since most of you are using your own laptops, you may want to check that you don't have like an instance of IIS or something else running. One way to do that is to do netstat-na. If you have Cygwin installed, you can even add grep listen, and you should see, for example, all the ports that your machine is listening on. If you don't have grep installed, you just do na, and then you just have to manually kind of scroll through this list, which becomes a bigger list. And you kind of have to...
STR.
Sorry?
You just find STR on Windows.
Okay, even better. I don't use Windows enough, but fair enough. Find STR, I guess. Okay, so now, assuming you don't have anything running on port 8080 and port 8005 and port 8009, which hopefully are less prevalent, you just be able to basically do Catalina space run. I know that there is this startup and shutdown scripts in here that look very inviting. I don't like to run these because what they do is they start Tomcat in a separate window. And I actually like to have a dedicated window just for starting and stopping Tomcat. Okay? So when I'm done with Tomcat, I hit Control C, that kills it. If I go and usually clear my screen, and then I go and run it again like this, and I start it up again. Okay, that's how I would like you to be running Tomcat in this class, because that way you will be running it in the foreground. Okay, so from the bin directory, just do Catalina space run. You actually obviously don't specify the .sh on Windows. Okay, I highly also recommend, especially for those of you that are on Windows, to adjust your scroll back buffers for your command prompt where you're running Tomcat. And the way you do that is you can right click on your toolbar, go to the properties, and in the layout tab, you can change the scroll back buffer from 300, which is the default, to something like 5,000 or more. Basically, so that you can scroll back. And the reason why we care about this is because later on, Spring and Hibernate are going to be spewing stuff in here, and you want to be able to see what that is. So it's the buffer, the layout buffer, the height of the screen buffer. So change it to like 5,000 or higher. I don't care. And you can have it to remember it, so the next time you don't have to do this. You can also enable the quick edit mode, which is also useful sometimes if you want to be able to quickly select something and paste it somewhere. Got it? Okay. Now, once you do that, you should be able to go in your in your browser, go to localhost 8080 and see a page that looks like this. If you do, then you're all good. There is no default username and password for the Tomcat manager. That's what you mean? There isn't one. You can set it up. We don't really need it, but if you want to know how to set it up, all you need to do is click on the Tomcat manager, click on cancel, and then read the documentation right here that will tell you how to set it up. Okay. So, anyways, there isn't one anymore by default, which is good. Unlike JBoss, for example, where you can just do a Google search for who's running JBoss with an unrestricted, username and password, so you can log in and start hacking their server. Anyway, that's basic Tomcat. Now, what we want to do is start up Eclipse. Have all of you downloaded Eclipse? Yes? Does anyone not have Eclipse downloaded? Okay. Do you have JVM?
Yes, I do.
Okay. Which version?
1.6.
Okay. So what can happen is that what you need to do is go into your system properties and add a variable called Java Home. In fact, this is good for pretty much all of you to do. So in Windows, one quick way to get there is to hit Control Break on your keyboard. That's a shortcut to it. And that will open up the System Control Panel. Okay? Switch to the Advanced tab. I guess, I don't know, in Windows 7, I'm not sure exactly what that looks like, but I guess it should look. Okay? Advanced, and then click on Environment Variables. And under System Environment Variables, add a variable called Java Home. So the difference between startup and run, so basically, first of all, just let me quickly explain that. If you do Catalina start, that's exactly the same as you doing, startup. Okay? Those two things are equivalent. Okay? Now, the reason why I don't like the startup or Catalina start is that they run Tomcat in the background, which on Windows means launching a separate window. And the reason why I don't like that is because if you screw up your configuration of Tomcat and there's a problem, that separate window will simply disappear and you will not see where the problem was, and you're going to have to then open up the log file, but which you will not do. You will call me, and then that will delay the class time, and then we'll all wait until we figure out what the problem is. Had you been running in the foreground, you would have seen what the problem is, and you would have avoided that trouble. Okay? So I prefer that you run it in the foreground while developing. Okay? So in fact, what I like to do is do rm-bat, rm startup, rm shutdown. Now there's no question about how I'm going to run it. Well, I guess I can still do Catalina start, which hopefully I won't do, so Catalina run. So now that we resolved the fact that we should have really downloaded the 64-bit version of, and again, it's the Eclipse IDE for Java EE developers. So this is what you needed to download if you're running Java 64-bit. I'm gonna wait for those of you that are running they don't have Eclipse yet installed to install it. So we'll actually take a break from Eclipse and Tomcat integration. We're gonna go back to Tomcat, okay? So let me just go back to my slides so that the rest of you can at least finish the installation or the unzipping of the Eclipse. And by the way, Eclipse you can unzip it anywhere. I don't care where you unzip it, okay? So program files, C drive, not important. When you start it up, it'll ask you for a workspace. It's helpful to have the workspace be in a directory where you can easily CD into it. I again recommend directories with no spaces, but sometimes that's not an option depending on which version of Windows you have. So I mean, it is an option, but if you want to keep it in your home directory, it becomes a little bit of a problem. So it doesn't matter what it is, as long as you remember where that workspace is, and we'll talk about how to access it. So anyway, coming back here to the Tomcat Servlet container, we already kind of discussed it. It's a free implementation of Servlets and JSPs. There are all these configuration files, blah, blah, blah. I don't want to bore you with things that, it's not really important for you to remember. You can refer back to this page if you need to remind yourself of what Tomcat is capable of. We'll see the relevant parts of Tomcat as we go. All you need to know is how to start and stop Tomcat, which is what we are going to explain, at least for the time being. Now, let's just come back to discuss some of these basics. Web technologies. I mean, Rajesh, not you Rajesh, the other Rajesh, Rajesh number 2, mentioned the difference between CGI and servlets. Well, this page kind of explains or contrasts servlets and JSPs to some of the other technologies, just to kind of give you an idea what are the competing technologies outside of the Java web space. So, for example, CGI, the Cold Fusion. The PHP, the ASP, the .NET stuff, for example, the Ruby on Rails, a lot of Python frameworks are out there. These are all different competing technologies. Okay, I think, of course, a lot of the enterprise Java world would agree that Java and servlets tend to have a very, you can basically, if you consider web development, there are all these different axes that you can stretch a framework in based on how fast things are, how easy they are, what's the learning curve, what's the scalability potential, what's the cost of adding new features potential, and so on and so on. So they're all different in different ways. So for example, CGI is super easy because it's available everywhere. It takes half an hour to explain and we can get going. But it's super inefficient, tends to be super insecure, and so on and so on. Cold Fusion actually sits on top of servlets and JSPs, but it's in a sense, to a large extent, a dying framework. Not too many people are investing, new projects with Cold Fusion for good, for good or bad reasons. It's just how it is. PHP is a very, very, good technology. Facebook was built on PHP, but in general, it doesn't scale as well as some of the other technologies. Not because just it's a scripted language, but just because it's being that it's a highly dynamic language and it doesn't offer a good set of kind of Java EE-like frameworks that everyone agrees on. There's basically there are too many best practices and too many people kind of reinventing the wheel, and it's not very complete. So the cost, the PHP is really easy to get started with, but the cost of adding new features to PHP, at some point becomes too much, right? So the cost of the first feature may be 1, but the cost of 100th feature may be like 17, 18, 20, 100. I don't know what it is. But, with Java, the cost of or Java servlets and JSPs, the cost of the first feature is going to be actually quite expensive because there's quite a bit of setup to it. But the cost of the 100th feature, presuming you follow the best practices, should be marginally less and less and less, right? just because it scales as a development environment. And as from performance point of view, Java tends to be very, very efficient. And we'll talk more about that later. But for those of you that have been using Java, you should hopefully already know that. ASP is really, really good. The .NET as a framework is, like I said, probably the most direct competitor to Java EE, especially in the enterprise world. But there are others out there, that they're not even on the list, like all the Python stuff and the Ruby on Rails and Groovy on Rails and stuff like that, which we'll talk about later. But some of these are just not. They're not as widely deployed yet, and maybe they'll never be. But they have their own niches that you should consider if you're evolving your web technologies and you're considering what to use. But serverless and JSP is they take a good balance between a good performant language, not too hard to learn, a lot of options from implementation side, a lot of options from the kind of frameworks that extend it and so on, and very, very scalable. Okay.
Is
go ahead.
Ruby on Rails a competing technology to? It's another web technology.
Yes. So that's exactly what that is. So Ruby on Rails is in fact a competing technology, and it's in many ways better than serverless JSPs because they take convention over configuration approach. So the cost of the first feature and the cost of the 100th feature are very low. The cost of maybe 300th feature becomes potentially more expensive, especially if you go out of their framework. So they're not as flexible, if you will, as say serverless and JSP-based technologies can be. But that's not to say that you can't build amazing web websites, enterprise applications with Ruby on Rails. In fact, you can. We do a lot of Ruby on Rails training. A lot of people migrate from Java to Ruby on Rails. But then I think that Ruby on Rails plays a special role in small to medium websites. Whereas Java is mostly for medium to large. And Java is much better when scalability, when performance matters. Ruby on Rails just does not scale the way Java does, and it never will, at least not the way Java does.
Why do you say so?
Because Ruby is a much more expressive language, much more dynamic language. It's much less efficient. In Ruby, everything's an object. Even primitives, there's no primitives. Integers are objects. Java specifically chose integers to be scalar values because they're much easier to optimize. Rails is a great framework. It's not that Rails itself necessarily won't scale. It can, but the community developing Rails is not focused on addressing the big problems of the enterprise, like transactions, distributed transactions, big caching issues, and so on, the way they are focused on smaller scale problems. But it's mostly Ruby as a language will never achieve the performance of compiled Java language. Even though Ruby you can run in JVM as JRuby, it just compiled Java versus compiled Ruby doing it's exactly the same thing. Java is going to be orders of magnitude potentially faster. Just how it is.
I also heard that Ruby on Rails is single-threaded.
Well, yes, in a sense, depending on how you run it, but that's changing. But yes, that is, Mongrail and the way typically it's deployed. Yes, that tends to be the case. So it's great, like I said, for small to medium, but you tend to hit scalability issues very, very quickly as soon as you at the scales, for example, that you guys care about, semantic. So CGI versus servlets, I already mentioned this. So this is kind of the recap of what you brought up, Rajesh. So CGI, this is just contrasting something that's, the most basic to something that's potentially the most featureful. CGI is every script is a separate process, runs within, outside of an application server, like within some kind of a web server like Apache. Servlets are, as we will see, servlets are kind of are synonyms to, are counterparts to CGI scripts, and they basically are these stateful Java objects that are loaded once, and they handle multiple requests in memory, and Java provides all the threading for us out of the box, or specifically Tomcat does through the Java threading semantics. Advantages of servlets. So we'll define servlets in a moment, but for the time being, think of servlets as the things that handle our HTTP requests. So servlets are written in Java. So because they're written in Java, they have all these advantages of being portable, being very performant, having access to rich Java libraries, high level. You don't have to deal with low level semantics. They're much more secure than a lot of the native stuff because Java tends to be more secure. They're very efficient. They get loaded only once. They have optimized at runtime by the Java's just-in-time compiler, and so on and so on. So this is an example of a sample servlet. It's not all that exciting. You can see it's a class that extends something called HTTP servlet. It has a method called doGet, takes a request and response. Reads from the request, writes the response, and that's it. Not very, it's actually even not even how a servlet should be written, but that's a very simple servlet. Advantages of JSPs, they have all the advantages of servlets, and we'll explain that JSPs are servlets, and I'll explain exactly what JSPs are. JSPs basically look and feel like HTML. They are it's a templating technology that sits on top of the servlet technology and makes it easy for us to create these rich templates in essentially Java language, and we can implement it so that it looks something like this. We have HTML code, and then whenever we have some dynamic code, we can put straight Java. Although again, this is not a recommended way of doing things, but you'll see in a moment exactly how to use JSPs and servlets. Now, before we get there, before we explain what servlets and JSPs are, let me explain one more concept. This is kind of important to understand. So, in the Java EE world, this diagram looks better in your book than it does on my screen, so feel free to open it in your book on slide 16. Basically, Java EE is an application server, right? That's what we run in. An application server usually has a whole bunch of services, some of which may be integrated, some of which may be completely independent of one another. Often these services are managed within a context of a container. So for example, there's something called an EJB container. There's a servlet container, and so on and so on. Now, Tomcat doesn't have any other containers but the servlet container. So basically, on Tomcat, these other containers don't even apply. So we're really concerned just about this servlet container because those others don't exist. Now, within a servlet container, the way Tomcat is generally structured is that there's here something called a connector, or whatever, just something called a connector that accepts connections from outside clients. Now, those connections can come in various different ways, various different ports. That's not really even for us to worry about at the moment. What happens is that a connector grabs a connection and then grabs a thread from a pool of available threads, usually, although there are different ways of managing this, and then assigns a thread to that particular connection, or that particular, usually it's a request, but you can think of one connection equals one request, if you want to dumb it down. Now what then happens, that thread drives the request to the rest of the Tomcat execution path, right? So that thread goes and reads the request from the raw bytes, which is usually HTTP, and then creates some kind of an object to represent the request in Java. It then takes that request object to a web application that it finds, and there will be different kinds of web applications you can have deployed. And in fact, here we have XYZ applications. You can have 50 different applications on a single application server, or there could only be one, depending on how you want it implemented. And then within that application, finds a servlet that's responsible for handling that particular request. So ultimately, we write that servlet. That servlet is something that somehow gets embedded within that application, loaded once, and then it handles a request and produces some kind of response that gets sent back by that thread through the connector back to the client. Does that make sense? Okay, cool. So what's a servlet? Now, does anyone care, those of you that have done servlets before, to try to define what a servlet is without reading this? Ultimately, I would say, so you're right, so servlet is a web component, right? Is defined by a Java EE, by a servlet spec, which is part of the Java EE umbrella of specifications. It's a class written in Java that gets instantiated, as you rightly pointed out, into an object. And then as an object, it accepts usually an HTTP request. In 99.9% of the time, it will be an HTTP request. But you're right, it can be used for things other than HTTP. So it accepts an HTTP request, reads the HTTP request, usually, for example, to understand the parameters of the request or who's submitting the request. It does something in the response to the request, writes to the response of the request, which is actually the response is delivered to the servlet as an object called response, and then it's finished. So effectively, the servlet is what I like to say handles the HTTP request and produces some kind of an HTTP response. So it's not strictly, it's not specific to HTTP, but most of the time it is HTTP. And it usually reads from the request and writes the response. Although it's possible for a servlet not to actually handle the request, it can delegate the request to someone else. That's also an option. In that case, it almost acts like a filter, but that's not necessarily the way we think of servlets. Okay? But you're both very close.
So you need to pass it both the request and the response object.
Right. So you don't. The container does. Yeah. So we write the servlets. The container uses the servlet. So a very simple HTTP request, a very simple servlet would potentially just handle the request and produce the response at the point the request is made. But in majority of applications, where we don't have very, very simple requests, we generally tend to involve a whole slew, of other objects that do things for us. So usually, a servlet is not meant to implement any kind of business logic. Usually, a servlet is nothing more than an entry point into our application that reads the request, the HTTP specific requests, converts them into an application request, have our application, which is standard Java. So for those of you that say, oh, I just know Java, that's good, because most of the time you're going to just be programming standard Java. So the standard Java handles the request as a Java request that doesn't even know that it came from the HTTP world, produces some kind of response, presumably as an object. The servlet that handles that takes the response and either converts that response into something that the browser can understand, like HTML, or potentially directs the response to something like a JSP, which is a template that renders HTML out of that response. And that's what we will see. So we do not instantiate a separate servlet for every request. A servlet is instantiated only once. So consider the following diagram where multiple requests basically diverge into the servlet, grab a thread, and those threads hit the servlet. So for example, say this request 1, so the request for servlet 1 and then request for servlet 1, they will basically think of there should be another line here that shows that there's 2 requests for servlet 1. Okay, basically the servlet 1 will only be loaded once, and multiple requests can all diverge onto that servlet by multiple threads executing the servlet at the same time. So we have to describe what executing a servlet means, but we will in a moment. Does that make sense? Okay. Now, servlet lifecycle. So I'll explain the lifecycle, and then we're going to go and play around with servlets. First and foremost, let me show you something. I'm going to go over here to, just Google and type servlet API, and I guess I'm going to be servlet API, and it's showing, interestingly enough, it's showing me like Tomcat 5.5. Doesn't matter. It's an older version. Doesn't matter. Okay. Some API of servlet. Okay. And you'll notice that one right here is a definition of a servlet. It's basically an interface that has these methods. The main method is called service, which takes a request and response, which gets executed every time a request comes in that matches that particular servlet. Here's a method called init that is called once by the servlet container to initialize the servlet with some configuration. And there's a method called destroy, which basically allows the servlet to, it's a callback that allows the servlet to destroy itself. Think of the init as a constructor, the destroy as a deconstructor, if you want to kind of think of it in C++ terms. Okay? There is no, servlets actually have to be created with no public constructors, or sorry, constructors that take no arguments. If you want to have a constructor, you can have one there, but they must not take no arguments. Other than that, basically, these two other methods are kind of whatever. They're not even important. They're usually provided. This method is something that you can implement to say whatever you want, and servlet config is something that gives you this servlet config object that you get here. So it's kind of stupid that these methods are even here. Now, this servlet we're not going to be actually ever implementing it directly. What we'll be using is a servlet called HTTP servlet. Whoops. Yeah, HTTP servlet extends from something called generic servlet and implements the servlet. And for some stupid reason, implement serializable. Servlets never get serialized, but it's stupid anyways. And basically, the servlet, you'll see, has these methods service. So service, there are two service methods. And then has other methods like do, get, do delete, do put, do trace, and so on and so on. I'll explain these methods in a moment. Okay? This is the servlet that we'll be implementing. So, let me explain the life cycle. First and foremost, a servlet life cycle is controlled by the servlet container. We will never instantiate a servlet. We will never dispose of a servlet. The servlet container, Tomcat, will do this for us. We will just define a servlet and map a servlet and have the servlet be executed by the container as needed. Okay? The servlet container will automatically, whether lazily, on the first request or preemptively on startup, go and instantiate a servlet, create an object, initialize it by calling the init method, and then keep it around. And as long as the requests that match that particular servlet, and we'll understand what that means, that servlet will run the service method. So basically, this method will get executed. Okay? And then when we're done with our application, we shut down one of our application, or we shut down the entire application server like Tomcat, then the destroy method gets invoked to basically allow us to clean up. Does that make sense? Okay, cool. So, initializing a servlet. At this point, I might as well actually be showing you this in real code rather than in a slide code. So let's take a look at this. Have all of you been able to set up Eclipse? To get it going? So now it works? It works for you as well? You're all good? Perfect. Cool. So what I would like you to do is let's just set up Eclipse for Tomcat. So integrate the two. Go into your preferences. So open up Window. Sorry, your case is going to be under Window Preferences. In my case, it's under Eclipse Preferences. But basically, start up your Eclipse Preferences. Okay? So just a different menu, but you should hopefully get to this page. So over here, you'll notice there's because we're using the Java EE version, there should be a section called Server. So please expand that section and click on this Runtime Environments. Then in your case, this will be empty. Okay, so let me go and kill mine as well. Well, actually, if I do, then here, I'll remove it, okay? And then click on Add, choose Tomcat 6 under the Apache, which should automatically be expanded if it's not expanded, and click on Next, and then select the directory where your Tomcat is installed. So in my case, you can just browse to the directory. So, whoops, not under internals. So, Tomcat training. In my case, it's Java Web Dev, and then Tomcat. And then click on Open. And the JRE should be the default JRE. I mean, you can select a particular one, doesn't really matter. And the name is going to be automatically assigned here. So once you select this, the name is automatically going to, everything's going to be automatically assigned. And you click on Finish. And boom, this should start up here. Okay? Done. Perfect. Now, you'll see a section right here called Servers, and you can kind of expand this, and you can even take a look at the server, and you even can go and say Run As. You can probably start and stop server right from here, which we don't really care about doing directly. Later on, I'll show you how you can run stuff on the server from within Tomcat, although that's not how I generally run it.
I don't have it. the server?
Don't worry if you don't have it yet, because it may not show up until you run it for the first time. Okay, now,
How do we get to the project explorer?
sorry?
How do we get to the project explorer?
So if you're running Eclipse, you by default you will be seeing a when you welcome screen. Close the welcome screen. On the left-hand side, you should see the Project Explorer. If you don't see it, under Windows, show Open Perspective, open up the Java EE perspective. So it may be under Other. You say Java EE, and the Java EE will have the Project Explorer here. If you have other stuff like Outline and some other stuff on the side, other views, they're kind of, most of the time, not even useful. So I just close mine. I just have the two views, the Project Explorer, and then this is the view where I'm going to be editing stuff. Got it?
I don't see the servers.
Don't worry if you don't see them just yet.
Oh.
Okay? So now, let me go and have you guys set up a first and the most basic project, the Hello World project, then we're going to go over the Eclipse stuff, and our food is getting here. So let me show you. Go into the File, New, and then click, it may not show up here, but you want to select the Dynamic Web Project. If it doesn't show up under File, New, go under Other, so File, New, Other, and under the Java EE, please select, sorry, Java Web, not Java EE, somewhere here, or Web. Select Dynamic Web Project. So File, New, Other, Dynamic Web Project. Click on Next, and give your project name, like for example, Hello World. Now this is kind of like, so you can see that it automatically chooses the target runtime which we previously created. It chooses some particular version of this. This is not even important. You can click on next, next, next. You can click on, the source and blah, blah, blah. We can configure a whole bunch of stuff. When we don't need to, we can just say finish and we're done. Okay? So we now have a project called Hello World. So all you need to do is create a new project, assign it a name, click on finish. Now, and this we're doing just so we kind of test out an environment. I mean, we're going to go well beyond Hello World very, very quickly, okay? So under the source, click on File, New, and click on, there should be, if you don't see it, there should be here something called Servlet. If you don't see it, you can go Other, and again, you can go under Web Servlet and click on Next.
Under source, you said?
Yeah, so if I selected source, I just clicked on source and then I said File, New. It's not even important. As long as you're selecting the project, it should automatically know where to go. It automatically chooses the source directory, okay? Give it some package, like for example, example. So here's our package called example. And class name could be like Hello World Servlet.
So you select a new package under source?
No. So let me show you again. I selected source. I said File, New. Okay? And if you don't see servlet showing up here, you can go Other, and then again under Web, you select Servlet.
Okay, got it.
Okay? You click on Next. It automatically selects as the project. So it automatically selects as the source folder. You say package, like for example, example. You say class name Hello World Servlet. And then you click on Next. Okay? Now, what this will do, it will automatically pick some URL mapping for us, which happens to be this /Hello World Servlet. I'll show you later on where this shows up. I just want you to test your environment. You click on Next, and it automatically asks us, for example, whether to have constructors, inherited abstract methods, whether to have do, get, do, post, blah, blah. I don't care about constructors. I don't care about inherited abstract methods. Or sorry, I'm just going to use the do, get. I don't care about the do, post. Let's just select the do, get, and inherited abstract methods. And click on Finish. All that this does, well, does a little more. It creates a simple class that looks like this. and it has a single method called doGet that does, takes in request and response and throw some exceptions. Okay? So let's do the hello world. Type response dot get writer dot print line hello world. And if you want to, some browsers sometimes complain about they don't necessarily know how to deal with the content. It doesn't hurt to say response dot set content type to be text/plain. It's not required in general, but doesn't matter. We might as well put it here. So all I did is I said response.getWriter.println blah blah. I'll explain what these things are after the break. And we're going to actually go and write some servlets. We're going to quickly go over the servlet API, and you guys are going to get to write some servlets, okay? And filters and JSPs. So we get this out of the way.
What was that automatic deployment?
So let's see. Okay? So after you're done with this, let's try to run it. So one way you can run it is you can right click on this hello world, and you can say, so right click on this and say run as, and you can say run on server. That should be one of the options. You see this? So if you do that, so you don't have to right click. You can also go and say click on this, say run, and then run as, and then run on server. That's easier. Big fan of right clicking. So anyway, run on server, and now it'll still ask you which server, whatever, localhost, blah 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 blah, and you click on finish. You can say next if you want to, blah blah blah. It's not even important. You can just say finish. And what it will do, it will actually run the server within Tomcat. Okay? And sometimes it has problems because my server was already running. Whoops. So yes, sorry. Don't forget that if you had Tomcat already started, you need to shut it down first. Because you can't have it running more than once. So do it again.
What's the proper way to shut down?
Just Control-C it. It's not a proper way for production, but for our purposes, it's proper enough. So Control-C it to kill Tomcat. So go back here. So again, run on server, and click on finish. It should start it. And you should see basically something that looks like this, which is fine. And if you now type in hello world servlet, you should see something that looks like this. Bless you. So we created a project, dynamic web project. We created a servlet. In that servlet, we just did hello world using the response.getWriter.println. And we ran our project on server, which started Tomcat within Eclipse and opened up a pseudo web browser right within Eclipse as well. And now we're seeing basically what the project should be producing. Of course, if you don't like to be using this pseudo web browser, you can copy this URL, go into your normal web browser, paste this, localhost 8080, so it's hello world servlet, like this, okay? Doesn't matter how you do it, but you need this full URL. The reason this part of the URL is the name of our application, this part of the URL is the URL that we by default chose to use to map to our servlet. I'll explain the mapping after the break.